Hello friends, welcome to our Genius Junction channel. Friends, today our topic is preparation and structure of diborane. This is the most important topic for BSc first year chemistry students whose SEM 1 is coming soon. So the important question, it's a 10 marks question. Explain the preparation and structure of diborane. First of all, let's know about the preparation. Preparation of diborane. Method 1. Boron trichloride react with hydrogen in the presence of discharge electrical tube to form diborane. As you can see the equation, here we mentioned 2BCl3 plus 6H2 in the presence of discharge electrical tube to form diborane with a byproduct HCl. It is also known as hydrochloric acid, which is a strong acid. Next method, boron trifluoride react with sodium hydride to form diborane. 2BF3 plus 6NaH gives rise to B2H6 plus 6NaF. Here you can see that I have written the equation both in words and in symbols. You can write in this manner to gain more marks. Let's go to third method. Boron trifluoride react with lithium aluminium hydride in the presence of dry ether to form diborane. Friends, do you know the formula of lithium aluminium hydride? Yes, it is LiAlH4. So here's the equation 4BF3 plus 3LiAlH4. In the presence of dry ether, we get the product diborane along with lithium fluoride along with aluminium fluoride. Here comes the fourth method. Sodium borohydride reacts with iodine to form diborane. 2NaBH4 plus I2 gives rise to B2H6 plus 2NaI plus H2. Hydrogen gas is evolved. Next topic is structure of diborane. So as we learned in the first topic that how to prepare diborane. Now let us see how the diborane is. That is what structure of diborane. So diborane resembles with ethane, but diborane is electron deficient compound because it has 2 electrons less formation of BB bond. So what is this electron deficient compound? Electron deficient compound is nothing but deficient means loss. So it has 2 electrons less formation of BB bond. Friends, do you know what is the ethane formula? Okay, let's see about the formula of diborane. Formula of diborane is like as ethane. Ethane formula is C2H6. Here's the structure. Total 14 electrons. Because of 7 bonds, each bond contain 2 electrons. So here 3 and in the middle 1. Total 7 bonds. Each bond contain 2 electrons. So 7 twos are 14 electrons. So what is the formula of ethane? C2H6. It is an electron sufficient compound. Now let's come to diborane. Diborane means di means 2, borane refers to boron. So 2 borons, 3 hydrogens on one boron and another 3 hydrogens on another boron. So how can the bond exist in between? Let's find it. Here we can make a difference that total 12 electrons because of 6 bonds. Diborane formula B2H6 electron deficient compound. That's why we referred here it as electron deficient compound because it has 2 electrons less formation of BB bond. To find more about this structure, we came to an experiment that is nothing other than but X-ray diffraction experiment. Structure of diborane is studied by X-ray diffraction experiment. According to X-ray diffraction experiment, diborane contains 2 types of hydrogen bond. First, terminal hydrogen bond. Second, bridged hydrogen bond. In structure of diborane, terminal hydrogen atoms are present on the plane of the molecule but bridged hydrogen atoms are present above the plane and below the plane of molecule. So friends, do you know what is terminal? Terminal refers to the last. Terminal refers to the last. So last hydrogen atoms are present on the plane of molecule, but bridged hydrogen atoms are present above the plane and below the plane of molecule. BHT, that is terminal bonds, are very stronger than BHB bridged bonds. And here comes the real structure of diborane. These hydrogens are terminal hydrogens, and the hydrogens in between boron are bridged bonds, that is bridged hydrogen bonds. Here you can see the bond angle between this is 122 degrees and here it is 97 degrees. Let's study about the nature of bonding in diborane. In diborane, every boron atom undergoes sp3 hybridization as a result to form 4 sp3 hybrid orbitals. Out of 4, 3 hybrid orbitals contain single electrons, but 1 sp3 hybrid orbital is vacant in every boron atom. Boron hydrogen terminal bonds are formed by overlapping between single electron of sp3 hybrid orbitals and 1s orbital of hydrogen. Two boron hydrogen boron bonds are formed by overlapping between single electron of sp3 hybrid orbital of one boron atom, 1s orbital of hydrogen, and vacant sp3 hybrid orbital of another boron atom. So this BHB is also called as bridged bond or two electrons three centered bonds or banana bond or electron deficient bond. It is also known as tau bond. Here comes to its electronic configuration of boron. You know that atomic number of boron is 5. So the electronic configuration will be 1s2, 2s2, 2p1. Here you can see that it is in ground state. If we give some heat, then it comes to excited state. In excited state 2s1, it becomes 1s2, 2s1, 2p2. One electron jumps from s orbital to p orbital and becomes sp3 hybridization. sp3 hybridization. Here the vacant orbital also involves in hybridization. So sp3, that means 1s orbital and 3p orbitals, which means totally 4 hybrid orbitals are involved in sp3 hybridization. But in this case, only 3 sp3 hybrid orbitals contain single electrons and one sp3 hybrid orbital is vacant. That's what we say in all this theory part. And here these single electrons forms bond with hydrogen 1s orbital and forms terminal bonds, and the remaining vacant orbital of one boron atom and 1s orbital of hydrogen atom and the single electron of another boron atom forms the bridged bond. As you can see here, the bond length is 1.19, 1.33 Armstrong, 1.77 Armstrong. What information can you draw from that? That in diborane, order of bond length is BB, BHB, BHT, and this is what the order of bond length. So finally, type of bonds in diborane are two types. 4 BHT bonds, that is terminal bonds, and 2 bridged bonds, BHBB, bridged bonds. Next, it comes to properties of diborane. Diborane is colorless and unstable gas. Diborane forms high boranes like B4H10, B5H9, B5H11 at higher temperature. Diborane react with ammonia at higher temperature to form borajol or boragine. Diborane plus ammonia at high temperature forms borajol or boragine. 3B2H6 plus 6NH3 at temperature 220 degrees Celsius forms 2B3N3H6 plus 12H2 gas. So friends, you can write this question to gain 10 marks in your SEM 1 exam. If you found this video useful, please hit the like button, and if you haven't subscribed my channel, please do subscribe, and don't forget to comment how the video is. Until then, meet you in the next video. Bye bye. Take care.